Where's Rick? He's here somewhere. I think he's here. Well, maybe not. How's everybody doing today? It's Monday morning. Um, Today is going to be a little bit unusual. I don't have any work plans, so there's several things that I need to do here at the house. I need to do repairs, several things that have to be done. I want to start off today by talking a little bit about positive thinking. Now, one of the things that you'll find a lot in the world today are these so-called self-help gurus, coaches, and so on. Some people can benefit from getting that reinforcement, but I think that a lot of this is much better in person than it would be through some type of program or some type of online interaction. A one-on-one video conference is definitely better than being alone, but I think in our normal world, we have to have connections with real people and real things to be able to verify what we are doing or what we plan to do. But anyway, what is this? Well, everybody knows it's a plant. This plant's a couple of years old and it's growing in this container. Now, in order for this plant to stay alive, I have to water it. I have to give this plant water every couple of days, because if I don't give the plant water, what will happen? Well, this will happen. It will dry out and die. And the plant will turn into basically this, which will eventually break down and become soil. So this is a very basic concept. But let's say that you were this plant, and this plant wants to grow. It wants to become a large tree, but it can't. And why not? It's in this container. No matter how much this plant wishes, thinks positively, and does whatever it needs to, it's not going to be able to grow because its roots that are trying to come out of the pot, they have nowhere to go. Even though the plant receives sunlight, it can't grow. So, what can we learn from this plant? Well, we can learn a lot of things. But I'm going to go ahead and move this out of the way and talk about something else. I mentioned before water. We all know what water is. Here's water. Water can take many forms, as evidenced by this glass. What's inside of this glass? Ice. If I add water to the ice, you'll notice that I have 3 forms of water. 3 forms? All I see is solid and liquid. But what you can't see around it is a vapor. And if you look, see where it's cold? Water is being formed on the outside of this glass. This is known as condensation. How can that be? Well, that's because we're surrounded by water vapor. Again, this is all basic stuff. Anyone in elementary school knows these things. Well, let's take a look at something else. What is this? This is a seed pod from a moringa tree. Inside of this seed pod, we have seeds. Now, what is a seed? This is a seed. If I put this seed in the dirt, I pour water on it, and I keep the seed watered, what will eventually happen? Well, it will grow. And it will start to grow into some type of plant. The moringa tree is actually a tree. It can grow to 30 feet tall, and it gets bigger and bigger. Now, how can that be? How can something this small, that just doesn't look like anything, grow into a large tree? Well, that's because it has a structured system built in. But here's the thing. If that seed stays inside this house, it never goes outside, it never reaches soil or moisture, it just sits in the house, what's going to happen to it? Well, eventually it's going to dry out and decay and turn to dust. So without the right environment, this seed will never produce anything. What's this? Of course, it's an egg. Everybody knows what an egg looks like. This was just laid by a duck this morning. Now, is there a duck in here? Well, sure, there's a duck in here. But the question is, how do I get the duck out? If I crack open this egg right now, am I going to get a duck? No, of course not. Because it takes time for the duck to develop inside the egg. Now, how do I develop the duck? Well, I put it into a warm environment, which allows energy to penetrate the egg. This stimulates the cells inside the egg along with the living material that is within, as well as whatever it needs, and it will begin to form. It will form an embryo and eventually will become a duckling, which will crack its way out of the egg and go out into the environment, begin to eat, and grow into a full-size duck. Now, one concept that was the reason I started the YouTube channel is this very simple idea that everything in the world tends to become greater disorder. For example, this seed. If I don't give it what it needs to grow, it's going to break down and turn to dust. So it will no longer be a seed. Here's another example. You know what this is. Sodium chloride. How do you make sodium chloride? Well, you take sodium metal and you have to mix it with hydrochloric acid. This is a reaction which then produces salt. Now, water itself is a product of a reaction. Water, which is a liquid, is actually a product of two gases, hydrogen and oxygen. And you know what happens if you take hydrogen and oxygen and put them in the same space? Well, they're going to be two gases mixing together. But if you raise the energy of those particles just enough, a reaction will take place. We call it an explosion or fire. Anyone that has seen the movie of the Hindenburg dirigible that caught fire and burst into flames, well, we know that was filled with hydrogen and mixed with oxygen in the atmosphere to produce water. And here's the water. But for those of us that live in a place like Florida, we're surrounded by the Gulf of Mexico and Atlantic Ocean. What's the difference between the water in, let's say, Lake Okeechobee and the water in the Atlantic Ocean? Well, the water in Lake Okeechobee does not have as much salt in it. Now, if I take two containers of water that are roughly equal, I'm going to take this salt and I'm going to pour it in one of these containers. Notice that the salt is already mixing with the water. Now, some of it settled to the bottom, some of it got into the water. If I stir it around a little bit, this mixing will take place much faster. Now, if I was to mix dirt with water, I could simply shake it up, let the dirt turn the water dark, and I leave the water sitting long enough, what will happen? The water will separate from the dirt will settle to the bottom. But in this case, you'll notice that the salt, although some of it is on the bottom, there's some of it in the water, and we humans, we can actually taste this. It's not really that salty yet, but eventually this salt will mix with the water and make it taste salty. It does taste a little different than this water. You can taste the difference, but it's not as much. If I keep pouring salt into the water, it's going to keep mixing. But you see, there's still some on the bottom of the water. Now, why do I think that this is going to mix? Well, it's because I know a basic concept of physics, and that's the concept of entropy. And with entropy, things tend to go from a higher energy state to a lower energy state. We know that salt, unless it has chemicals added to it, will tend to clump up into a lump. We also know that, if we wear socks, eventually we wear them for a period of time, and what happens? They get holes, okay? Nobody wants to wear a sock with a hole in it because your toe is going to stick out. It's very annoying. And what happens over time? As you move around, the hole gets bigger until it's no longer good for anything. Now, all I did was expand this hole. How can I make this go back to the way it was? I can't, because of entropy. If I was to rip this apart, it won't be able to be put back to the way it was. So, let's see if I can. Trick is getting a good grip on it and tear it apart. There it goes. So again, this basic concept of entropy is in everything. That goes in the rag bucket. So, understanding some of the basic concepts of physics basically shows us that what we can do in this world is not limitless, no matter how much we wish. For example, there are a lot of people out there that have this ridiculous idea that you can speak things into existence. All you have to do is wish for it or hope for it, and you'll get it. And that's total garbage. Anyone that tells you this is a scam artist, or maybe they're just not that. All right, I'll give you an example. The last time somebody told me that you can speak things into existence, I said, okay, I'm going to fly to Chicago without an aircraft. I'm going to sit here and I'm going to levitate. I'm going to go to Chicago. Well, I'm sitting here and I'm not flying. I can't get out of this. I'm stuck in this couch. If I don't do something, I can't get out. Well, what if I was to flap my arms, you know? Could I fly? Well, no, I can't fly. Why? Because all I'm doing is moving air around me. If I was a bird, I would be designed a specific way, and I would have feathers, and then I would have the wings that go out. And if you've ever watched a bird fly, their feathers can actually move in the air. So they have maximum air resistance when pushing, and then when the wings go up, they have less air resistance. So again, these are all very basic concepts that are in the world of physics. So again, you can't violate these laws of physics. This is the reason why you can't run your car on this. It is impossible. Anyone that tells you that you can run your car with water is lying to you. Water is not a fuel source. Water is actually the result of a reaction. It's a compound. I've had people say, well, water is the most abundant element on the earth. This is not an element. This is a compound. Now, some people would say, well, it's all a conspiracy theory. They've lied to us. The earth is flat. You know, there's all these things that are supposed to be true. Well, we can prove very easily that the earth is not flat. And I can prove very easily that water is composed of hydrogen and oxygen. Very, very simple. I can do this through electrochemistry. In fact, we know more about physics today than at any time in our history, and yet people continue to fall for a bunch of nonsense, a bunch of lies. Why do they do that? Well, because everybody wants something for nothing. One thing that the idea of entropy tells us, entropy at its basics is the degree of randomness of energy in a system. The lower the entropy and the more ordered and less random it is. Okay? So to lower entropy, we have to make things less random. If I took this egg and I broke it open, what would it take for me to put it back together? Once I've broken this egg, can I get a duckling out of it? Well, no. What if I scrambled the egg? Could I take a scrambled egg and turn it back into a sunny side up egg? No, I couldn't. So the thing is, once something becomes more random, there's no way to put it back. If I was to break this container into broken glass, could I put the pieces back together? I might be able to try to glue it together, but it's not going to be the same. If I was to get a piece of paper, I don't have one in front of me, and well, here's one. Let's say that I rip this piece of paper. I'm going to rip this piece of paper in half. Can I put it back together? No, I can't. So once something becomes more random, there's no way to put it back to the way it was. Now, can I recycle the paper? Of course I can. I could take all these pieces of paper and I could put them into water. I could blend them up into fibers, put them through a screen with some type of adhesive, and I could create a new piece of paper. But there's a difference. The energy that it took to break up this piece of paper is a lot less than the energy it's going to take for me to blend this up and reform it into new paper. And this is another thing that a lot of people do forget. When you're recycling something, it's a law of diminishing returns. It's like plastic. Plastic can only be recycled a certain amount of times because of entropy. That plastic begins to break down every time that it's heated up and reformed, and it is no longer good. Now, I take plastic and I make something like diesel out of it, or I could make gas that I could use. That is a lower form of energy. So if I was to take plastic waste and turn it into fuel, there was more energy in the plastic waste to start with than what I use as fuel. And then when I burn that fuel, I get motion out of my vehicle. I can get work done with my equipment. There's a lot of things that I can do. But in the end, now it has dispersed into the atmosphere. The carbon dioxide, carbon monoxide, whatever else happens to be, water, all these things that were in that material have dispersed into the atmosphere. And even in the natural environment, although plastic lasts a very long time, that plastic will eventually break down into what it started with. So that big garbage patch you have out in the ocean where they've dumped plastic from Asia or wherever, or even a plastic bottle that's sitting out in the yard, it may be there for hundreds of years, but eventually it will break down and it'll go back to the carbon compounds that it came from. So the law of entropy, very, 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 very important. And remember, high entropy is correlated with high randomness, and low entropy is correlated with low randomness. So this container of salt and this water represent higher energy state. When the salt is poured into the water, the result is going to be a lower energy state. To separate out the salt from the water, I have to add energy to be able to go back to a higher energy state. And how do I do that? Well, I could dump this into, I could put it into maybe a stainless steel bowl or whatever, pour that in there, put it out in the sun, and what would happen? Well, eventually it would evaporate, the water would go back to the atmosphere, and I would be left with the salt. Then I could take that salt, grind it up in a blender or a grinder, and I could put that on my steak. So again, once you get some of the basics, it's easier to understand. Let's say that I bought a brand new car. Let's say that in 1969, I was able to go and buy a brand new 1969 Charger. For the first time in my life, I could buy a new car that I would actually like, because today's cars to me are garbage. They're ugly, and I don't even want to think about new cars. The worst part about new cars is not just the way that they look, but their complexity and difficulty to repair. But anyway, we're getting off topic here. I get that brand new 1969 Charger and I put it outside in the yard and I let it sit there and I never do anything to it. I never wash it, never run it, nothing. I come back in 50 years and what do I find? A gigantic pile of rust. The whole thing is destroyed. The tires have long failed. Every piece of rubber in that car is gone. Everything's rusted. There's holes everywhere. And why is that? Well, because in the environment we live in, you're going to have greater entropy. Now, if I was to take that car and put it into an environment of lower entropy, for example, an air-conditioned building, I put that car inside back in 1969, and in 2023, I open the door. Well, it looks a lot better, but it's still not ready to run. The tires are dry rotted, the belts are shot, I might be able to go and start it up, especially if it never had any fuel in it, never had any oil in it. Well, maybe it had some oil. I change the oil, I put fresh fuel, I get it started. It may run for a while, but eventually the radiator hoses are going to blow out. That plastic timing chain gear is going to fail. There's a lot of things I would have to do. Now, it's in a lot better shape than the one that was sitting outside under a tree, but eventually I'm going to have to replace a lot of those parts. And why is that? Well, that's because rubber and other plastics and other materials do not last. And even steel, as you know, will rust. So, as an example, here's a steel shelf from my library, and as you can see, look at this. There's rust. Now this shelf is from early 60s. It was out of an old library, and you can see that it's still mostly solid, a little bit of cleaning and repainting, it'll be as good as new. Here's an old hose, and as you can see, the clamps that hold it are rusted, and look, there's cracks. This hose will fail once it's exposed to its normal working environment. So, with these ideas in mind, it's very important to understand the limitations of the world we live in. You can talk about things and how positive they are and wishful thinking and all this other nonsense, prosperity doctrine, whatever. It doesn't work that way. The world we live in is not a world of free things. Nothing is free in this world. Everything that's in this world has to be worked for. Now you would say, well, again, let's go back to this seed. I plant this seed, it's going to grow on its own. And that's true. Nothing that I do is going to make this seed grow. Nothing. Well, I could do something that would kill it. I could pull it out of the ground. That I could do. And if you believe that you could speak things into existence, how about thinking of it this way? You can talk yourself out of things. You can say, well, I'm going to eat duck food and I'm going to be perfectly fine. I'm going to, everything will be good. Nah, I'm not going to try to adjust my lifestyle. I'm not going to stop smoking. I'm not going to stop drinking. Everything's fine. No big deal. I'm going to go into debt. I'm going to buy what I want. And I'm not going to worry about the consequences, which is just the way it is. Well, that's not the way it is. The reality is you have to have a lower source of entropy to get things done. If you don't have that, you don't have anything. By the way, you know what this is? Well, of course you do. You know what that is. But look at it. Why does it look like this? Well, because cockroaches have eaten the outside of the binder. Also notice that the pages are a little bit yellow. They're starting to disintegrate. So even though this, you can see the mold and mildew on this little card, even though this is the good book, it's still subject to the basic things that we have in the world we live in. Does that mean that this book is worthless?